Hi everybody. So we're going to finish chapter 10 off by having a look at some exam questions which are all taken from the new specification. So let's get started. What you should do is have a go at doing these yourself and pause the video, and then you can come back and see if you got the same answers that I did. Okay, so first thing I noticed when looking at this is our range is quite a weird range. It's between 360 and 540. And we've got a quadratic equation here, but it's not all in sine or cos. We've got this in sine and this in cos here. So because this one is in cos, we're going to replace the sine squared using 1 minus cos squared using our Pythagorean identity. And it's also worth noting that they want all of the answers to one decimal place. It does say here that solutions based entirely on graphical or numerical methods are not acceptable. This is explanation for me saying why you can't use the calculator just to get the answers, and also why you wouldn't be able to use like Desmos to get the answers. You do have to show the full pattern. Okay, so let's get going. We have the equation is 12 sine squared x plus 7 cos x minus 13 equals 0. So I'm going to replace my sine squared with 1 minus cos squared x. And I've then got 7 cos x minus 13 equals 0. So that becomes 12 minus 12 cos squared x plus 7 cos x minus 13 equals 0. So just writing that in a sensible order, that's minus 12 cos squared x plus 7 cos x, and then you've got 12 minus 13, which is minus 1. Now I'm going to go straight to my equation solver, where for this quadratic, a is minus 12, b is 7, and c is minus 1. And when I go onto my polynomial solver, so I have minus 12, 7, and minus 1, we get that cos x is either equal to 1/3 or cos x is equal to 1/4. So let's start off by doing the one that is equal to 1/3. I'll put a bit of a dotted line down here. So we know that x would be equal to the inverse cos of 1/3. So let's clear all of this. The inverse cos of 1/3. And we get either 70.5 degrees, or the other one is found by doing 360 minus that answer, which is 289.5 degrees. Now, remind us, the range is 360 to 540. So neither of these are actually going to be included. So I'm going to look at this one while I've still got it on my calculator, and I'm going to add 360 to it to see if it's still in range. And actually it's not going to be in range. So that one is not even worth adding 360 to it, okay? The other one, let's just get it back, which was our 70.5. If I add 360 to this second one, let me just quickly put this, the one I'm doing. If I add 360 to this, I get 430.5 degrees, which is in range. If I added 360 again though, it would not be. So this one can't be used, this one can't be used. In fact, the only answer I get from this one is 430.5 degrees, and that's to one decimal place. Now let's work on this second side that we've got over here. So x would be equal to the inverse cos of 1/4. Let's go to the calculator. The inverse cos, sometimes I just type it as 0.25. We've got 75.5 degrees. The other one would be 360 minus the answer, which is 284.5 degrees. Now, same pattern as before, neither of these are going to be inside the range. And actually, if I added 360 to that one, it still won't be inside the range. So let's just go back to the other one that we had, the 75.5. There's no point adding 360 to this one, it's going to go outside. So if I add 360 to this, I get 435.5 degrees, which is inside the range. So this one is not inside the range, this one is not inside the range, so it is only this solution that we have here, which means that our answers to this question are x is either equal to 430.5 degrees or 435.5 degrees. Only two answers, and that is because it is quite a small range between 360 and 540. So it's 5 marks for this. So you get 1 mark for knowing that you need to use the Pythagorean identity that we have written here. You get the accuracy mark for then coming up with the quadratic. We had a different quadratic where we just had minus 12, 7, and minus 1, but it's exactly the same, so you would still get that accuracy mark. Then using the solutions of the quadratic to give cos x equals, so we have that here and here. So there's no marks for doing this because it can be done on a calculator, so you should do it on a calculator. And then you get a mark for using the inverse cos on the values, getting these two values here. And so you get 430.5 and 435.5. Okay, here is another question. This is a 5-mark question, and what you've noticed is that, hopefully you've spotted this quite quickly, is we've got a strange range here, and our argument is 2 theta plus 10. So the thing I'm going to begin with is I'm going to change the range. So my current range is between 90 and 270, and I'm going to first of all make it 2 theta by doubling it. So it would be minus 180, 2 theta, and 270 times 2 is 540, and I'm going to add 10. So I need to make sure I add 10 to this, so it would be minus 170, 2 theta plus 10, and I'm going to add 10 to this, and I get 550. So this here is the range that I'm going to be using for this question. Okay, so we have sine of 2 theta plus 10 is equal to minus 0.6. So 2 theta plus 10 is going to be the inverse sine of minus 0.6. We're just going to solve this equation as normal for the green range that we've got written there. So the inverse sine of minus 0.6 is minus 36.87 degrees, minus 36.87 degrees. And then the second one that we would get from this for sine is 180 minus the answer, which is 216.87. Now we just need to make sure that we find all of the values that are inside this range. Remember, for this one, you can either add 360 or take away 360 from it. If you take away 360 from this, you are definitely going to go below this minus 170. But I think I can add 360 to it. So let's go back. There's my answer. If I add 360, I get 323.13 degrees, and if I added another 360, it's definitely gone outside the range there, so there's not much point in doing that. Okay, so this second one, which I usually like to do in this green color, I'm going to see what happens if I add or take away 360 from this. So I have 216.87. Well, if I add 360 to it, it has just gone over the top of that 550, so that one is not going to be useful. But if I take 360 away from it, I get minus 143.13. Minus 143.13. So all of these are in range. I now need to just finish off by doing some final calculations. So this is all 2 theta plus 10. Now to get to what theta is equal to, I need to do a couple of steps to all of these. First of all, I will subtract 10, and then I will half my answers. I will divide by 2. So let's go right back to the beginning. Let's start off with the minus 36 one that we have up here. So we've got minus 36.87, I will subtract 10 and then divide by 2. So I have minus 23.4 because it only wants it to 1 decimal place. That's why I gave 2 decimal places earlier on. Okay, my next one, I shall do 216.87. I will minus 10, press equals, and half it, 103.4. Then I've got 323.13 minus 10, divide by 2, 156.6. And my last one is from my minus 143.13. Whoops, minus 143.13. I'm going to take away 10, press equals, divide by 2, and I get minus 76.6. Minus 76.6. And you don't have to do this, but I'm probably going to write them in order. So I've got minus 76.6, minus 23.4, 103.4, and 156.6. Let's check that it's actually to do with the original range that was in the question. Yep, none of them are smaller than -90 and none of them are bigger than 270. Let's just check the answers for this one. I'm not going to go through all of it. I'm just going to highlight these so it's clear when I look back at this. So we've got -76.6, yep, -23.4, 103.4 and 156.6. Okay, so let's do a couple more here. Why don't you pause this one and have a go? This one definitely looks kind of trickier. Okay, show that this equation can be written in this form. So this one's nice and difficult. Let's just begin by thinking about what the issues are. So we have 4 cos theta minus 1 equals 2 sine theta tan theta. Now this equation has got no sine thetas and it's also got no tan thetas. So I think I'm going to try and deal with this tan theta as my first step. Now we know that tan theta is sine theta over cos theta. So I have 4 cos theta minus 1 equals, now the numerator of this fraction is 2 sine squared theta, and everything is being divided by cos theta here. So if I want to continue solving this equation, I'm going to multiply both sides by cos theta. Now when you multiply by cos theta, you need to multiply this and this by cos theta. So you get 4 cos squared theta minus cos theta equals 2 sine squared theta. Now you can see how we might start getting to this equation that we've got here. This looks like it could be one of those quadratics. Apart from I have a sine squared, so I'm going to replace the sine squared with 1 minus cos squared. So I'm going to replace the sine squared, make sure you put it in brackets, with 1 minus cos squared theta. I'm just going to add in a blank page here, so I've got a bit more space. Okay, let's keep going. 4 cos squared theta minus cos theta equals 2 minus 2 cos squared theta. It's a quadratic, so I want to get everything all put onto one side. So that becomes 6 cos squared theta minus cos theta minus 2 equals 0, which is exactly the thing that they wanted us to show that it could be written in this form here. Okay, now part B of the question is kind of classic for how they do these. So I'm going to write it up here so I can see the question nice and clearly. It says, hence, solve for this particular range here, this equation down here, giving your answers where appropriate to 1 decimal place. Now, I'm really interested in this word hence. Hence means you need to use this information and this information to help you to solve this one that you've got down here. So a bit of careful looking should tell you that there is something very much in common between these two equations that we've got here. They look exactly the same, apart from in this one, there is a theta here, here, and here, whereas this one, the argument is 3x here, here, and here. So if this equation can be written as this equation, we then should be able to make an assumption that this equation, which is the second blue one I've got written, without any extra working, I know that it can just be written as the same as this one, which I'm going to highlight in this orange color, except instead of with theta, I'm going to replace all the thetas, with 3x, just like happened in those blue ones. So it is going to be the same as 6 cos squared 3x minus cos 3x minus 2 equals 0. And I'm just going to make a big point here. This orange one and the other orange one match each other. Apart from instead of theta, it says 3x. And these blue ones match each other. Apart from where it says theta, it says 3x. And so now the rest of this question is just going to be about solving the trig equation. Now hopefully you've noticed this is a pseudo-quadratic. So a is 6, b is -1, and c is -2. So when I go to my equation solver and I do 6 minus 1 minus 2, you end up with that either cos 3x is 2/3, or cos 3x is minus a half. Okay, lots of work in this question. They have asked for this particular range, that it's between 0 and 90, but not including 90, you'll notice that. So we need to first of all change the range so that it becomes 3x. So this is the range that we are going to be using for the question. Let's start off with cos of 3x equals 2/3. So we will do the inverse cos of 2/3, which is 48 point. I'm going to just do a couple of decimal places here because we're going to be doing some division. So I'm going to do 48.19. And my other one is going to be found by doing 360 minus this, but it may not be inside the range. So let's just see what happens. So we've got 311, and actually that's bigger than 270, so I won't even need to write that one down, okay? So I'm just going to stick with my 418.19 there. Okay, let's keep going. So I'm going to divide by 3. I've actually already got it there, so I can do my answer divided by 3, and we get 16.1 degrees. Okay, that was for my cos 3x equals 2/3. Now I'm going to do my cos 3x is equal to minus a half. So 3x is the inverse cos of minus a half. Let's have a go. We get 120. And that is inside the range. My other one is going to be found for cos by doing 360 minus the answer, which is 240, and that is inside the range. So all I need to do now to go from 3x to x is I'm going to take these answers and divide them by 3. Well, 120 divided by 3 is 40, and 240 divided by 3 is 80. So the solutions that I have for this question, which was a lot of work, is 16.1 degrees, 40 degrees, and 80 degrees. And it just makes sense to check, is it inside the original range? So we've got these ones here. Yeah, the range is between 0 and 90, so we've definitely got those answers. Now, if I was in the exam, I would then go and use the solve n feature on my graphics calculator to check my answer. But actually, I've got a mark scheme here, which will save me a bit of time. So we've got 40, 80, and 16.1, which is exactly the answers that I have. Okay, we have got one more exam question to do. Okay, let's see how we go on this. Okay, so pause it and have a go. The range is between minus 180 and 180, and we've got some of these pseudo-quadratic type things, and they want 2 decimal places. Okay, this sine x is telling me that the cos squared x is going to be needing to change into the sine language, the sine squared stuff. So I'm going to replace the cos squared with 1 minus sine squared. Okay, let's get going. So we have 3 sine squared x plus sine x plus 8 equals 9 lots of 1 minus sine squared x. I'm going to expand and get everything all onto one side. So 3 sine squared x plus sine x plus 8 is equal to 9 minus 9 sine squared x. Adding the sine squareds, you get 12 sine squared x plus sine x, and then 8 minus 9 is minus 1. So on my quadratic equation solver, a is 12, b is 1, c is minus 1, which gives me a is 12, b is 1, c is minus 1. This gives me that sine x is either equal to 0.25, what am I doing, 0.25, a quarter, or sine x is equal to minus a third. Okay, I'm going to do these two separately, and bearing in mind the range is minus 180 to 180. So x will be equal to the inverse sine of a quarter which is 14.48 degrees because they wanted 2 decimal places, so 14.48. 14.48 degrees. And my other one is found by doing 180 minus the answer. So I have 165.52 degrees. Now, if I added 360 to this 165.52, it's definitely going to go over the range, and the same for the other one. But if I take away 360 from this one, you will see that, whoops, it also goes outside the range. So there's just these two answers, just the 14.48 and the 165.52. For the second half, I'm going to do the inverse sine of minus a third. So back to my calculator, the inverse sine of minus a third, and we get minus 19.47 degrees. That's one of them. And actually you can see here, if you added 360 to this, or if you took 360 away from this, it's not going to give you any other solutions. So there's no point in even kind of playing around with that. If you do add 360 out of range, take away 360 out of range. Okay, and for sine, the other one is found by doing 180 minus the answer. So you have 199.47. Now this is actually outside of the range, so we're not going to be able to use this one, but I will be able to use it if I take away 360 from it, and I get the minus 160.53 degrees. So I was able to find another one by subtracting 360, but I will not be able to use this, which means that the solutions are x is minus 160.53, minus 19.47, 14.48, and 165.52. Okay, I'm just going to highlight those so that it's really clear for me. These are my answers for when I want to check them out later. Now, part B says, hence, find the smallest positive solution to this equation, giving your answer to 2 decimal places. Well, there's that really, really important word again, and the important word I'm going to pick out is hence. Hence means you need to use this information to help you solve this information. So there's a few different things to notice. First of all, the equation is exactly the same. It may not look well, it's not exactly the same, is it? That's not true. It is almost exactly the same, apart from where there is x in this question, there is now 2 theta minus 30. Okay? The thing they want us to find, though, is the smallest positive solution of the equation. So, instead of my solutions saying x equals blah, 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 they will say 2 theta minus 30 is equal to this one, or this one, or this one, or this one here. Now, they don't want us to find just any of these, all of these solutions. They want us just to find the smallest positive solution. So you're going to have a look at all of these and think which is going to be the smallest positive solution. Well, if I add 30 to this, because of what we've got on the left-hand side here, it's not going to be positive. So there's no point in doing that one. Well, this one's never going to be the smallest one, because if I add 30 to it, it's not going to work. Now, although this one is negative, if I add 30 to it, it will become positive. If I added 30 to this one, yeah, it would be positive, but it wouldn't therefore create the smallest one. This is going to be the one that will end up producing the smallest positive solution for theta. So we have 2 theta minus 30. We're going to use the minus 19.47, and I'm going to solve that equation. So I'm going to add 30, and you'll see now how it goes to positive. Minus 19.47, add 30, we get 10.53. And then when I divide that by 2, we are going to get our smallest positive solution. Oh, didn't do that right. Let's divide that by 2, because it has to be positive. And we get 5.27 degrees, and that is to 2 decimal places. Okay. If you try it with all 4 of these values that you've got here, this one will end up being negative. This one will end up being positive, but it will actually be, it won't be the smallest one. I'll just show you that super quickly. 14.48. If you add on 30 and then divide it by 2, it's 22.24, and 5.27 is the smallest positive one that you can get. and it wanted the answer to 2 decimal places, which we did, 5.27. So, I need to double check why it's at 5.26. Okay, so we've got these different solutions for the first bit, 14.48, 165.52, 19.47, and 160.53. Those are the ones that we had up in green. For some reason, I changed it from, hang on a sec, 165.52. Oh, I have got them right. It's just they were in a different order. So they've got 5.26. Maybe I need to use the slightly longer version then of this 19.47 that I've got here. So I'm going to just quickly make some amendments there. Let's get a few more decimal places for that. If I do the inverse sign of minus, the inverse sign of minus a third, let's actually use a slightly longer version. So we've got minus 19.47122. And if I add 30 to this, I get 10.5287. And then when I do my answer divided by 2, I get, rather sneakily, when you use the rounded version, it doesn't work so well. You actually get 5.26 degrees. So there is a good lesson. Here, use the unrounded version. Okay. So lots of difficult exam questions there, but hopefully that's shown you all the things that you know about this topic. Okay, and that's us done with chapter 10.